Okay, so continuing with our next part of this, exponents, actually using them, right? Not just knowing what they are, but actually using them. In this lesson, so the last one rather, I'm sorry, you learned how to use exponents to indicate repeated multiplication. So we're going to take a look at what happens when we have multiplying things with power. So not just the fact that 7 squared means 7 times 7, but what happens when I multiply 7 squared times 7 cubed? So we're going to take a look at rules for that, things that make your life easier. Because we all know that 7 squared is 7 times 7, and 7 cubed is 7 times 7 times 7. Well, that makes 5 of them, since multiplication is both commutative and associative, so it's 7 to the 5th power. That's what we're looking at this time. If you've not done the vocab, please go back and do that real quick. So again, the rule that you will see in your vocab, multiplying numbers or variables of the same basis, you add the exponents. In other words, notice here 2 and 2, same base, right? So 2 cubed times 2 to the 4th. If we had to write it all out, you see that was 2 to the 7th. But you can say, oh, that's fine. That's 2 times 3 plus 4, right? Or 2 to the 3 plus 4, which is 2 to the 7th. In algebra, notice same base. They both have a's here. A to the m, whatever number that is. A to the n, whatever number that is. Technically, it's a to the m plus n. So that's the rule there. So for our example here, 0.3, this is technically to the first power, right? Don't forget that. If nothing's written there, it's to the first power. Times 0.3 to the third power. That's 0.3 to the 1 plus 3, which is 4. And you can multiply that and prove that it's 0.0081. Or what's this, 10, 100,000, 10,000? So 81 10,000ths. That's tough to say sometimes. So if I have a to the 5th times a to the 1st times b squared. Notice that b squared is a different, or that b is a different base. So it does not get included with these guys. So a to the 5th times a to the 1st is a to the 6th. The b squared just comes down as for the ride. Doesn't get added to them in any way, shape, or form because different base. Go ahead and pause, head into class kick. You've got a few to do there, and come back and check them. Alrighty, so example number 1 here. Let's see here. I need a pen. There we go. So I have right here, we have 0.2 squared times 0.2 to the 3rd power. So that's technically 0.2 to the 2 plus 3, which is 0.2 to the 5th power, which if you went ahead and multiplied that out, will give you, you ready? This one's kind of fun, 0.00032. And that's what, tenths, hundreds, thousands, 10,000s, 100,000ths. So it's 32 100,000ths. That's kind of fun. The second one here, m to the 5th times m to the 7th. So again, that's m to the 5th, or 5 plus 7, if I could spit it out, which is technically m to the 12th. That's it. There's nothing else you can do with it. Keep watching for another example from me. Alrighty, using the commutative property. So we're not changing the rules here. A couple things I want to point out to you here is, if you'll notice, right here, these guys, right, aren't the same base. But you're still going to multiply them like regular numbers. So negative 2 times 3 is negative 6. The other two here, I'll circle differently, these are the same base. They're both x. So that's x to the 2 plus 5. So it's negative 6, x to the 7th power. So again, to go back one more time, just to make sure here. Multiply the coefficients. Negative 2 times 3 is negative 6. X to the x squared times x to the 5th is x to the 7th. Nothing else you can do. You can't somehow combine something weird. Go ahead and pause, head into class kick, and work a few. Come back and check them. Alrighty, so on this first one here, again, multiply the coefficients. 6 times 3, right, is 18. A cubed, a to the 1st, is a to the 4th. Continue with the second one. Again, multiply the coefficients. Negative 5 times negative 3 is a positive 15. C squared times c to the 7th, that's c to the 2 plus 7, or c to the 9th. And then the last one here, 4 times 3 is 12. X squared times x to the 4th, that's x to the 2 plus 4, or x to the 6th. That's it. Raise your hand if you need help. I'll go through it with you. We'll draw it all out, whatever you need to do. Go and continue for another example from me. Alrighty. Now this one's a little different. Power to a power. So this right here does not equal 3 to the 2, right, times 3 to the third. No, not it. Instead, it's power to a power, and you have this in your vocab. So this is technically 3 squared. Let me write it out. It looks like this. It's 3 squared to the third power. So 3 squared. So it's 3 squared. Gosh darn it, that's tough to spit out. 3 times. So in other words, now if I were to do same base, right, this is 2 plus 2 plus 2 is 6. So it's 2 plus 2 plus 2, which is 3 to the 6th, which, by the way, is 729. More simply, though, if I have a power to a power, in other words, 3 squared raised all the way to the cube, that's 3 times 2, instead of adding like the other ones, that's how we get our 3 to the 6th, which again is 729 in this case. Algebraically speaking, again, this is one of those things you got to learn here. This is a to the, it's not 6 plus 2 because it's power to a power, so it's 6 times 2, or a to the 12th. We'll do some practice, don't worry. Go ahead and pause, head into class kick, and work a few there. Okay, so again, the rule of power to a power, right? So it's not power times a power, it's power to a power. 2 to the 4 times 2 is 2 to the 8th. C to the 5 times 4 is C to the 20th. And then m to the 3 times 2, so right, m to the m cubed squared, right, is 3 times 2, so m to the 6th. The answer's there. That's it for today's examples. You've got a book page to work today. Same thing again tomorrow, book page, and we'll do some more examples there. Give it a go. Check them out. Ask questions, please. You got to get this down.